Picture this. A clay tablet sits in a museum vault in London, 5,000 years old, covered in wedge-shaped scratches that look like bird tracks in mud. And on that tablet, ancient scribes describe something impossible. Gods descending from the sky. Not to punish humanity, not to demand worship, but to solve an engineering problem. An atmospheric crisis on their dying world. Using gold particles suspended in the air. Sound familiar? It should. Because that's exactly what Harvard scientists proposed in 2017 to save our planet from climate change. Now here's where this gets strange. These weren't just mythological stories. The Sumerian texts read like technical manuals. Mining operations with geological precision, genetic engineering procedures, astronomical calculations that require mathematics we didn't rediscover until the Renaissance. The detail is so specific that it makes you wonder, were these primitive myths, or were they something else entirely? The Anunnaki, that's what the Sumerians called them. And for decades, serious academics wouldn't touch the subject, too contaminated by ancient astronaut theories. Too embarrassing. But here's the thing. When you actually read the original tablets, translated by credentialed scholars who spent their entire careers studying cuneiform, what emerges isn't fantasy. It's a detailed record of beings with specific jobs, specific skills, specific technologies. In 1965, a German scholar named Adam Falkenstein compiled every single mention of the Anunnaki across all surviving Sumerian literature. Not YouTube videos, not fringe websites. Just the clay tablets themselves. And what he found was shocking. These weren't generic sky gods. They had organizational structures, hierarchies. Some managed mining operations. Others handled what the texts call genetic creation projects. Others tracked the stars with mathematical precision. Samuel Noah Kramer, one of the most respected Sumerologists of the 20th century, translated a text called the Atrahasis, and in that text there's a creation story. But it doesn't read like Genesis. It reads like a laboratory procedure. Mix clay with divine essence, specific measurements, specific steps. Let it incubate. The result? Workers. Designed for specific functions, built to mine, built to serve. Now you might be thinking, come on, that's just creation mythology. Every culture has those stories. But here's where it gets uncomfortable. The procedural specificity in these texts matches modern cloning protocols with eerie accuracy. Clay could mean organic material. Divine essence could mean genetic material. The steps described, mixing, incubating, the waiting period, they parallel what geneticists do in labs today with CRISPR technology. And it's not just one text, it's dozens, all saying similar things, all with that same strange level of detail that feels less like poetry and more like documentation. But let's address the elephant in the room. Why don't serious scholars talk about this? The answer is complicated. Academic careers live or die by peer review. Publishing anything that sounds like ancient aliens is professional suicide. One archaeologist told me off the record that the subject is toxic. Not because the evidence isn't interesting, but because the fringe theories have poisoned the well so thoroughly that any legitimate inquiry gets drowned out by noise. There's also a translation problem. Take one phrase that appears constantly in these texts. The Sumerian words can be translated two ways: descended from heaven, or came down from the mountain. Same characters, radically different meanings. One suggests divine beings from the sky. The other suggests people from the highlands. How do you choose? Most mainstream scholars choose mountain. Safer, more conventional. But here's what they can't explain away: the astronomical knowledge, the metallurgical precision, the architectural achievements. If these were just mountain people, where did they get knowledge that we struggled to rediscover thousands of years later? Think about this. Clay tablets from 5,000 years ago are still readable today. Sharp, clear, perfect preservation. Meanwhile, digital files from the 1980s are already unreadable. Obsolete formats, corrupted data, dead hard drives. Ancient stone is a superior archive to cutting-edge technology. Ironic, isn't it? The primitives understood data storage better than we do. And what's written on those durable tablets? Technical knowledge. The Muldotapin Compendium describes planetary movements, eclipse predictions, constellation maps. The Venus tablet records the rising and setting of that planet across decades, with accuracy you can verify using modern computer models. These weren't wild guesses. These were observations, requiring instruments we assume they didn't have. Now here's where the story gets even stranger. This pattern isn't unique to Sumer. Egyptian texts describe the Neteru descending from the heavens to teach agriculture, mathematics, and astronomy. Mesoamerican cultures talk about Quetzalcoatl bringing similar knowledge. The Dogon people of Mali have oral traditions about beings from Sirius, teaching them about that star's invisible companion, a detail they couldn't have observed without telescopes, but that modern astronomy confirmed is absolutely accurate. Either every ancient civilization independently invented the same mythology about sky teachers bringing technology, or something else was happening. Something that got recorded in the only language available at the time, the language of gods and myths. One deity appears again and again in Sumerian texts, Enki, and his role is fascinating. He's not a warrior god, not a storm god. He's described as a teacher. The tablet inscriptions read like course catalogues. Enki teaches mathematics. Enki teaches writing. Enki teaches metallurgy. Enki teaches agriculture. It's curriculum-like in its organization, as if someone was running a school and keeping records of what they taught. There's also a hierarchical structure that's oddly specific. The texts distinguish between the Igigu and the Anunnaki. The Igigu seem to be the administrators, the higher-ups. The Anunnaki are the workers, the ones doing the actual mining, the actual building. Wolfram von Soden spent years analyzing this structure in ancient texts, and he found something remarkable. These groups had specialized roles, functional divisions, like departments in a corporation. Some handled resource extraction, others managed genetic projects, others tracked celestial mechanics. It wasn't random. It was organized, efficient, like an operation designed to accomplish specific goals. And then there's the gold obsession. Every ancient civilization from Sumer to Egypt to South America hoarded gold, built monuments with it, covered everything in it. The standard explanation is symbolic value, religious significance. But here's what bothers researchers: the intensity of the focus, the industrial scale of extraction. Ancient mines in South Africa date back 40,000 years. The Great Orme copper mines in Wales moved 2,000 tons of ore. Why? Just for decoration? The Sumerian tablets offer a different explanation. The Anunnaki needed gold, not for jewelry, for their failing atmosphere, to repair radiation shielding on their home world. Sounds insane, right? Except modern materials science has discovered that gold nanoparticles can stabilize atmospheric molecules and reflect specific wavelengths of radiation. It's not decorative, it's functional. It works. And that's just one example. The more you dig into what these texts actually say, the more often you find technical claims that seemed absurd when first translated, but that modern science has quietly validated. Atmospheric engineering, genetic manipulation, astronomical precision, architectural acoustics. Over and over the pattern repeats. Now, I'm not saying ancient aliens definitely visited Earth. That's not what this investigation is about. What I'm saying is that these texts describe technological knowledge, real, specific, verifiable technological knowledge. Knowledge that ancient people supposedly didn't have. And whether that knowledge came from extraterrestrials, from a lost human civilization, or from sources we haven't even considered yet, it's there, in the clay, in the stone, waiting for us to stop dismissing it and start actually investigating it. The Atrahasis text describes mixing materials to create life with procedures that look remarkably like what scientists do with stem cells and embryos today. The astronomical tablets predict celestial events with mathematics that shouldn't exist for another 3,000 years. The architectural specifications describe acoustic properties and structural engineering that we struggle to replicate even with modern tools. This is documented. This is translated by credentialed scholars. This is what the sources actually say. So we're left with a question, a big one. Are we looking at mythology that coincidentally sounds like technology? Or are we looking at technology that was later mythologized because no one understood what they were describing anymore? The patents we file today for new inventions read like gibberish to anyone without technical training. Imagine trying to explain a nuclear reactor to someone in the Middle Ages. They'd describe it as a glowing stone that boils water using trapped sunlight. Sound magical? It's just technology described in the wrong vocabulary. Maybe that's what we're seeing in these ancient texts. Technology described in the only language available, the language of gods and miracles, because the scribes didn't have words for nanoparticles and genetic engineering and orbital mechanics. And if that's true, if these texts are actually technical documentation disguised as mythology, then everything we think we know about human technological development needs to be re-examined. Because we're not starting from zero. We're rediscovering. We're remembering. We're finding breadcrumbs left by whoever came before. But here's the part that should really make you pause. These ancient texts don't just describe technology that sounds vaguely futuristic. They describe technology that aligns with cutting-edge research happening right now. Gold nanoparticles for atmospheric engineering. genetic modification procedures, acoustic manipulation of matter. These aren't medieval dreams of flying carpets. These are specific, testable, real technologies. Which brings us to the uncomfortable question nobody wants to ask. If these were just primitive myths about gods, then why do the technical specifications they describe for atmospheric engineering with gold particles align so precisely with discoveries we've made in the last decade about plasmonic shielding and nanoparticle radiation reflection? Why does a 5,000-year-old tablet describe exactly what Harvard scientists are proposing to do right now? In 2019, scientists published something extraordinary in Nature Communications. Gold nanoparticles, they discovered, can stabilize fragile atmospheric molecules and reflect specific radiation wavelengths. A breakthrough in materials science. Cutting-edge research. Except for one uncomfortable detail. 5,000 years ago, Sumerian scribes carved the exact same claim into clay tablets. They wrote that the Anunnaki came to Earth desperate for gold, not for jewelry, not for temples, for their dying atmosphere, to create a protective shield around their world using suspended gold particles. And when those tablets were first translated, scholars laughed. Primitive mythology, Bronze Age fantasy. But here's what nobody expected. The physics actually works. So now we have to ask a question that makes a lot of people uncomfortable. Did ancient people somehow understand material science that we're only now discovering? Or is this just the most bizarre coincidence in human history? Let's start with what the texts actually say, because the detail is unsettling. The Sumerian tablets don't just mention gold vaguely. They describe collection operations, mining procedures, processing techniques. One tablet talks about extracting gold from seawater, which sounds absurd, until you learn that modern chemistry has confirmed gold exists in ocean water at concentrations of about 13 billionths of a gram per liter. It's there, exactly where the ancient text said it would be. Another text describes the Anunnaki needing gold to create what translates roughly as a shield of shimmering particles in the upper sky, a protective layer. And the tablets specify that this shield would reflect light from the sun while protecting against harmful rays. That's not poetic language. That's a technical specification for stratospheric aerosol injection. The same thing Harvard scientists are proposing right now with their stratospheric controlled perturbation experiment. But here's where it gets really strange. Gold shouldn't be the obvious choice for this. If you asked 100 people what material you'd use for atmospheric engineering, almost nobody would say gold. It's rare, it's dense, it's expensive. There are cheaper metals, lighter metals, more abundant metals. So why gold? Modern materials science finally has the answer, and it's going to blow your mind. Gold has properties that no other element can match. It doesn't corrode, ever. You can leave gold exposed to atmosphere, water, chemicals, and it remains absolutely unchanged. That's crucial for anything you're going to suspend in the air for extended periods. But that's just the beginning. Gold is the most malleable metal on Earth. You can hammer it so thin that it becomes translucent. A single ounce of gold can be beaten into a sheet covering 300 square feet. And when you get gold particles down to nanoscale, something remarkable happens. They begin to interact with light in ways that seem almost magical. This is where plasmonics comes in. In 2022, researchers published a study in Advanced Materials showing that gold nanoparticles can manipulate light at the quantum level. When photons hit these tiny gold particles, they create something called surface plasmon resonance. The electrons on the gold's surface oscillate in response to light, creating localized electromagnetic fields. And those fields can reflect specific wavelengths of radiation while letting other wavelengths pass through. You can tune it. You can control it. You can create a shield that blocks harmful ultraviolet radiation while allowing visible light and warmth to reach the surface below. It's exactly what you'd need to protect a planet with atmospheric damage. And NASA already uses this technology. Right now, gold coatings protect spacecraft from radiation. The James Webb Space Telescope has gold mirrors because gold reflects infrared light better than any other material. Satellite solar panels are coated with gold to prevent degradation from cosmic radiation. The Apollo astronauts had gold-coated visors on their helmets. The International Space Station has gold layers in its protective shielding. Every major space agency independently discovered what those ancient texts describe. Gold works. Gold protects. Gold reflects. Gold survives. Now, you might be thinking, okay, that's interesting, but it doesn't prove anything. Maybe the Sumerians just got lucky. Maybe they happened to choose gold for symbolic reasons, and it coincidentally has the exact properties needed for atmospheric engineering. Maybe. But then there's the Harvard Project. In 2017, scientists proposed the Scopex experiment. The plan? Spray reflective particles into the stratosphere to combat global warming. Create a thin layer of suspended material that would reflect a fraction of incoming solar radiation, cooling the planet below. And guess what they're considering using? Calcium carbonate, sulfur compounds, and metallic particles, including gold. The exact same solution that ancient texts describe, to solve the exact same problem. Atmospheric crisis, radiation management, temperature control. 5,000 years apart, and we're arriving at identical answers. Hold that thought, because there's something else you need to know. We're not just theorizing about this anymore. We're actively mining for the resources to do it. Multiple companies, backed by hundreds of millions in investment, are developing technology to mine asteroids. Planetary resources, deep space industries. They're targeting platinum group metals, rare earth elements, and yes, gold. The business plan is identical to what the ancient texts describe. Go to space, extract resources, bring them back for planetary engineering projects. We're literally recreating the Anunnaki business model. And we're doing it because the engineering logic is sound. But here's where the story takes another turn. Ancient mining operations weren't primitive, not even close. Archaeological evidence from Bulgaria shows copper alloys from 5000 BCE that required smelting techniques we thought were invented thousands of years later. These alloys have precise ratios of copper, arsenic, and antimony. The temperatures needed to achieve this? Over 1,000 degrees Celsius. The atmospheric control required, sophisticated beyond what any Bronze Age furnace should have been capable of. In Serbia, researchers found evidence of copper extraction from 5500 BCE, with efficiency levels that approach modern industrial standards. Someone understood reduction chemistry, Someone understood oxygen control in furnaces. Someone knew exactly how to separate pure metal from ore, using techniques that wouldn't be officially documented until the 19th century. And then there's the Witwatersrand Basin in South Africa, the richest gold deposits on Earth. 40,000 years of mining activity, tunnels, shafts, systematic extraction. The scale is staggering. And here's the geological twist that nobody talks about. These deposits are unusually accessible. Compared to gold distributions on other rocky planets we've studied through spectroscopy, Earth's gold is remarkably concentrated in mineable locations. Mars? Gold is there, but it's diffused, scattered, hard to extract. Venus? Buried under crushing atmosphere and extreme heat. Mercury? Surface temperature varies from 430 degrees Celsius in sunlight to minus 180 in shadow. Good luck building a mine. But Earth? Stable climate, accessible deposits, liquid water for processing. It's not just a good place for mining, it's the perfect place for mining. If you needed gold for planetary engineering, and you could choose anywhere in this solar system to get it, you'd choose Earth. Every single time. The engineering logic is airtight. And gold's usefulness doesn't stop with atmospheric applications. Modern medicine is discovering that gold nanoparticles can stabilize fragile molecules and deliver drugs to specific targets in the body. The particles are small enough to pass through cell membranes, but stable enough to carry their payload intact. Cancer researchers are using gold nanoparticles to target tumors. The particles accumulate in cancer cells, and then doctors hit them with focused radiation. The gold amplifies the radiation effect, destroying the tumor while sparing surrounding tissue. It's the same principle. Molecular stabilization, targeted delivery, controlled interaction with electromagnetic radiation. Whether you're using it to protect a planet or cure a disease, gold does things no other element can do. Now let's talk about why any of this would be necessary. Atmospheres are fragile, terrifyingly fragile. In 1985, British scientists discovered the ozone hole over Antarctica, a gap in Earth's protective shield caused by chlorofluorocarbons, chemicals we'd been pumping into the atmosphere for decades without realizing the damage. Within 40 years of industrial-scale production, we'd torn a hole in the layer that protects all life on Earth from ultraviolet radiation. 40 years. That's all it took for one civilization to damage an atmosphere that took billions of years to form. Now imagine a more advanced civilization, more industry, more energy consumption, more atmospheric stress. The damage would happen even faster. And the solutions would need to be equally advanced. You'd need materials that could survive in harsh environments, materials that could reflect specific wavelengths, materials that wouldn't degrade or chemically react or fail after a few decades. You'd need gold, because nothing else works as well. And that brings us back to the ancient texts. Every major civilization had a gold obsession. Egyptians covered entire temples in it. The Incas called it the sweat of the sun. Mesoamerican cultures hoarded it with religious intensity. The traditional explanation? Symbolic value, religious significance. Gold represented the divine because it doesn't tarnish, and therefore it seemed immortal. But here's what bothers researchers who actually look at the numbers. The scale of extraction, the industrial intensity. Ancient mines moved millions of tons of ore. The labor investment was enormous. The social organization required was staggering. All for symbolism? All for decoration? Or was someone teaching these civilizations that gold was crucial, that it needed to be collected, that it had applications beyond mere beauty? The texts say yes. The Anunnaki needed gold. They taught humans to mine it. They collected it. They used it for engineering purposes that ancient scribes could only describe in the vocabulary available to them. Shimmering shields in the sky, protective layers against burning rays from the heavens, divine materials that never aged or corrupted. Strip away the mythology and you're left with materials science. Now comes the test. The final question that determines whether any of this is real or just pattern matching. If you were a scientist today, and you needed to design a planetary atmospheric shield, and you had no knowledge of ancient texts, no cultural bias, nothing but physics and chemistry and engineering logic, would you choose gold nanoparticles? The answer from modern researchers is yes, unequivocally yes. Gold's optical properties, its chemical stability, its ability to be processed into nanoscale particles that remain suspended in atmosphere, its interaction with specific wavelengths of light, all of it points to gold as one of the best choices available. Maybe not the only choice, but definitely on the short list. And that's what makes this so hard to dismiss. We're not forcing ancient texts to match modern science. We're watching modern science independently arrive at the same conclusions that ancient texts describe. The Harvard Geoengineering Project, NASA's spacecraft protection, medical nanoparticle research, asteroid mining proposals. Every field that touches on atmospheric engineering or radiation protection or molecular stabilization eventually discovers that gold works, just like the texts said it would 5,000 years ago. So, we're left with this impossible situation. Either ancient people understood material science at a level that took us until the 21st century to rediscover, or they were recording what they were told by someone who already knew. Someone who had solved these problems before. Someone who came to Earth specifically because we had accessible gold deposits and the planetary conditions needed to extract them. The Anunnaki. The gods who descended. The engineers written in clay. They said they needed gold for atmospheric repair, and modern science says that would actually work. The technology is valid. The engineering is sound. The application is practical. We can't ignore that. But if the gold explanation checks out, if the atmospheric engineering makes sense, if the mining operations and metallurgical knowledge and planetary selection all align with what advanced beings would actually do, then we have to ask the next logical question. The one that makes even skeptical scientists uncomfortable. Because the texts don't just talk about mining. They talk about genetic engineering, creating workers, designing humans with specific traits, mixing divine essence with earthly clay to produce modified beings built for labor. And that sounds insane, until you look at what we found in our own DNA. Anomalies, fusions, changes that happened suddenly, changes that look less like gradual evolution and more like deliberate editing. If gold technology explains the mining obsession, what about the genetic engineering claims? Could the Anunnaki really have manipulated human DNA? And if so, Do we carry physical evidence of those interventions in our chromosomes today? You have 46 chromosomes. Your parents each gave you 23. Simple math, basic biology. Except for one problem. Every other great ape on Earth has 48. Chimpanzees, gorillas, orangutans, they all have 48 chromosomes. We have 46. 2 are missing. Or more accurately, 2 got fused together. And when geneticists examined chromosome 2 in humans, what they found made them deeply uncomfortable. Because it doesn't look like a natural fusion. It looks engineered. Like someone took 2 separate files and deliberately merged them into one streamlined package. One geneticist called it a cleaner user interface for consciousness. So now we have to ask the question nobody wants to ask. Did human DNA get edited? And if so, who did the editing? The ancient texts have an answer, and it's going to make you question everything you thought you knew about human origins. Let's start with what those texts actually describe. The Atrahasis is a Mesopotamian creation story that Samuel Noah Kramer translated in the 1950s. And when you read it, it doesn't sound like mythology. It sounds like a lab procedure. Step 1. Take clay, which in ancient vocabulary could mean any organic material. Earth, soil, biological substrate. Step 2. Mix it with divine essence, blood of a god, genetic material from an advanced being. Step 3. Place the mixture in a container. Let it develop. Wait for a specific period. 14 iterations are mentioned. 14 cycles. Step 4. Birth the workers. Beings designed for specific functions. Mining, building, labor. Now here's where it gets disturbing. In 2010, the J. Craig Venter Institute created the first synthetic life form. They called it Mycoplasma laboratorium. And the process they used? Take existing cellular material, insert designed genetic code, place in a controlled environment, wait for cell division, monitor for 14 generations to ensure stability. The same steps, the same waiting period, the same concept of iterations to verify the design works. 5,000 years apart, and the procedure matches. Coincidence? Maybe. But then you look at the chromosome fusion. Humans have chromosome 2. It's large, it's distinctive, and it has something that shouldn't be there. In the middle of the chromosome, geneticists found telomeres. Now, telomeres normally appear only at the ends of chromosomes. They're like protective caps, bookends. But chromosome 2 has them in the center, along with remnants of a centromere, the structure that helps chromosomes divide during cell reproduction. What this means is undeniable. 2 separate chromosomes got fused together, and the telomeric signatures are still visible. Like someone cut and pasted 2 files and forgot to clean up the formatting marks. The evidence is right there, in every cell of your body. But here's what makes scientists nervous. This fusion is unique to humans. It happened after we split from chimpanzees, and it happened in a way that created a viable, stable chromosome. That's statistically unlikely. Chromosome fusions usually cause serious problems: miscarriage, developmental disorders, non-viable offspring. Yet this fusion worked perfectly, and it spread through the entire human population. Every person alive today carries it. Not some people. Not most people. Everyone. Natural evolution or targeted modification? Hold that thought, because there's more. In 2003, researchers discovered something called the FOXP2 gene. It's crucial for speech. Without it, humans can't form coherent language. But here's the strange part. Chimpanzees have FOXP2 too. And the difference between their version and ours? Just 2 amino acids. 2 tiny changes in the genetic code. But those 2 changes gave us language, complex grammar, abstract thought, the ability to teach concepts that don't physically exist, time, causality, hypothetical scenarios. None of the other apes can do this. They have the same basic genetic structure. They have larynxes. They have brains. But they don't have those 2 amino acid changes. And without those changes, they don't have language. 2 changes. That's all it took to transform communication ability. Sounds like a targeted upgrade, doesn't it? Now you might be thinking, okay, but evolution makes changes like that all the time. Random mutations that happen to be beneficial. Natural selection doing its thing. And you'd be right. Except evolution usually works slowly, gradually, over millions of years. The FOXP2 changes happened fast, within the last few 100,000 years. Right around the time modern humans emerged. Right around the time the ancient texts say the Anunnaki created modified workers. And those changes spread through the entire population with remarkable speed. Too fast for natural selection. Just fast enough for intentional distribution. But if you think that's strange, wait until you hear about RGAP11b. In 2021, researchers at Kyoto University did something remarkable. They took the human-specific gene RGAP11b and inserted it into marmoset monkeys. And the monkeys' brains changed. Their neocortex, the part responsible for complex thought, expanded dramatically. 1 gene, 1 insertion. And suddenly you have primates with enhanced cognitive capacity. The researchers were stunned, because it proved that consciousness, advanced thinking, human-level cognition, all of it can be engineered with minimal genetic changes. You don't need to rewrite the entire genome. You just need to know which switches to flip. And RGAP11b is unique to humans. It's not in chimpanzees, not in gorillas, not in any other primate. Just us. It appeared in our lineage about 5 million years ago. And when it appeared, brain capacity started increasing. Fast. Could this be natural? Sure. Could it be intentional? The Kyoto study proves that's possible too. We now have the technology to do exactly what that gene does naturally. We can engineer consciousness. We can create cognitive upgrades. We're doing it in labs right now. So the question becomes, if we can do it today, could someone have done it to us back then? The ancient texts say yes. The Anunnaki modified primitive humans, gave them enhanced brains, enhanced language, enhanced capabilities, created workers smart enough to follow complex instructions, but not smart enough to rebel. At least not immediately. But there's another piece of evidence that's even more troubling. Mitochondrial Eve. In the 1980s, geneticists analyzing mitochondrial DNA made a discovery that shocked the scientific community. All humans alive today can trace their maternal lineage back to a single woman. She lived in Africa somewhere between 150,000 and 200,000 years ago, and every human on Earth carries her genetic signature. Now, she wasn't the only woman alive at that time, but she's the only one whose lineage survived. Every other maternal line died out, completely. And this one line, Eve's line, spread across the entire planet and became the foundation of all modern humans. In genetic terms, it's called a bottleneck, a moment when genetic diversity collapsed and then exploded outward from a single source. And bottlenecks usually mean something dramatic happened, a catastrophe, a mass extinction, or in this case, possibly a deliberate creation event. The ancient texts describe exactly that. The gods created modern humans. Not all the hominins, not the earlier species, just us, Homo sapiens. And we replaced everyone else. Fast. Neanderthals, gone within a few thousand years of our arrival. Denisovans, extinct. Homo erectus, vanished. We didn't just coexist with other human species. We replaced them. And the speed at which it happened suggests we had an advantage they didn't. Not just cultural, not just behavioral. Genetic. We were the upgrade, the new model, version 2.0. And we came preloaded with features the older models didn't have. Language, advanced cognition, social complexity, tool innovation. And we spread across the world with a speed that suggests purpose, direction, as if we were designed to replace what came before. Now let's talk about something that most people think is just religious mythology. Adam's rib. The story that Eve was created from Adam's side. Sounds impossible, right? You can't clone a human from a rib bone, except you actually can. In 2005, researchers discovered that bone marrow contains stem cells that can differentiate into multiple tissue types, including reproductive cells. Your ribs contain bone marrow, and that marrow contains the genetic blueprint to create another human, not through sexual reproduction, through cellular manipulation, cloning. So when the ancient text says Eve came from Adam's rib, maybe it's not poetry. Maybe it's procedure. Extract stem cells from bone marrow. Use them to grow a genetically related but distinct individual. The science works. We can do it now. Could someone have done it then? And here's where the Garden of Eden story gets even more interesting. Because when you read it as a scientist instead of a theologian, it doesn't sound like a paradise. It sounds like a containment facility. Think about it. Specific boundaries. Don't go past these trees. Specific rules. Don't eat from that one plant. Specific monitoring. God walking in the garden in the cool of the day. That's not divine omniscience. That's scheduled inspections. And what happens when the subjects break containment protocol? They get exiled, removed from the controlled environment, released into the wild to see if they can survive independently. It's what researchers do with every genetically modified organism. You test them in controlled conditions first, then you release them to see if they're viable in the real world. The serpent? In laboratory terms, that's contamination, an unexpected variable, something that gets into your controlled environment and disrupts the experiment, introduces changes you didn't plan for. Every geneticist knows this problem. You design an organism with specific traits, but then mutations happen. Outside influences occur. The result diverges from your original plan. And here's the uncomfortable part. We're seeing the exact same challenges today. In 2018, a Chinese scientist named He Jiankui shocked the world by announcing he'd used CRISPR to edit the genes of twin girls. He was trying to make them resistant to HIV. Noble goal. Except the gene editing caused off-target effects, changes he didn't intend, mutations in unexpected places. The scientific community condemned him, not just for the ethics, but because he proved something everyone already knew but didn't want to admit. Genetic engineering is messy. You can't edit one thing without risking changes to other things. The genome is interconnected. Touch one part, and effects ripple through the whole system. So, if the Anunnaki did engineer humans, we'd expect to see evidence of trial and error, failed attempts, unexpected mutations, genetic diversity that doesn't quite fit the pattern. And guess what? We do. We have blood types that cause fatal complications in mixed pregnancies. We have genetic diseases that serve no evolutionary purpose. We have traits that seem badly designed for survival. It's almost like we're the result of an experiment that worked well enough, but not perfectly. Good enough for production, not good enough for quality control. But here's what really keeps geneticists up at night. The more we study human DNA, the more we find genes that seem too perfectly designed for their function. Not evolved gradually, not cobbled together through random mutation, but optimized, efficient. Like someone wrote the code knowing exactly what they wanted it to do. The FOXP2 gene for language, the RGAP11B gene for consciousness, the chromosome fusion that streamlined our genetic structure. These aren't scattered random changes. They're targeted improvements to specific functions: brain capacity, communication, cognitive processing. If you were designing a worker species, these are exactly the upgrades you'd make. Smart enough to follow complex instructions, verbal enough to coordinate in groups, conscious enough to innovate solutions, but not so advanced that they question the system. And we're doing it now. Human-animal chimeras, scientists growing human organs in pigs, inserting human brain cells into mice to study consciousness, creating synthetic embryos with designed traits. Every lab working on this is recreating the scenario described in ancient texts, taking existing biological material, modifying it, creating something new. In 2019, Japan approved experiments to grow human-animal embryos to term. The goal? Growing human organs for transplant. The method? Insert human stem cells into animal embryos and let them develop. It's the clay and divine essence procedure. Same concept, modern terminology. We're becoming the Anunnaki, whether we realize it or not. Whether we admit it or not. We're genetically modifying life. We're creating designed organisms. We're playing with the code that determines consciousness, intelligence, capability. And every step we take proves that the ancient texts weren't describing magic. They were describing biology. Advanced biology that we're only now beginning to understand. But here's the question that changes everything. If genetic engineering requires this much knowledge, this much precision, this much trial and error, even with our modern technology, then whoever did it, thousands of years ago, needed more than just laboratory skills. They needed mathematics. They needed to calculate breeding cycles, predict genetic drift, time interventions to planetary cycles and seasonal changes. They needed astronomy, advanced astronomy, the kind that requires understanding orbital mechanics, planetary motion, celestial cycles that span generations. The ancient texts say the Anunnaki had that knowledge, that they mapped the stars, predicted planetary movements, calculated celestial events with precision that shouldn't have been possible without telescopes, without computers, without thousands of years of accumulated observation. But genetic manipulation requires more than laboratory skill. It requires sophisticated astronomical knowledge to calculate breeding cycles, predict genetic drift, and time interventions to planetary cycles. Did the Anunnaki possess such knowledge? And if so, how advanced was their astronomy? 3,000 years before Galileo pointed a telescope at the sky, Babylonian astronomers carved something impossible into clay. A star catalog called the Malapan. It predicts planetary positions, eclipse timings, equinox calculations, with accuracy that modern computer models confirm is correct. Without telescopes, without calculators, without even understanding that Earth orbits the Sun. How? The texts say the Anunnaki taught them, showed them the movements of the heavens, gave them tables and formulas that would remain accurate for millennia. And for centuries, scholars dismissed this as mythology, Bronze Age priests making lucky guesses. Except the guesses are too accurate, too consistent, too mathematically sophisticated to be accidents. So we're left with an impossible question. Did ancient astronomers spend thousands of years making observations so precise they rival modern measurements? Or were they taught by someone who already knew? Let's start with what they actually achieved, because once you understand the scope of their knowledge, you'll realize why scientists are so uncomfortable discussing this. The Malapan isn't just a list of stars, it's a comprehensive astronomical reference. Constellation positions, rising and setting times, planetary motions, eclipse prediction formulas. The mathematics alone require understanding concepts that supposedly weren't discovered until the Renaissance. Trigonometry, algebraic equations, geometric models of celestial mechanics. In 2018, researchers published a study in the Journal for the History of Astronomy. They used computer models to recreate the night sky over Mesopotamia during the 2nd millennium BCE, and they checked every star position listed in the Malapan. The result? The ancient positions matched the actual sky with remarkable precision. Not approximately, not close enough. Exact. These weren't rough estimates. These were measurements accurate to fractions of a degree. The kind of precision that requires either sophisticated instruments or knowledge transmitted from an advanced source. But here's where it gets even stranger. The Venus tablets of Ammisaduqa. These clay tablets record the appearances and disappearances of Venus across multiple decades. When Venus rises, when it sets, how long it stays visible. The patterns repeat with mathematical regularity, and modern astronomers have verified every single observation. The tablets match computer models of Venus's actual movements during that time period. Not just the general pattern, the specific dates, the specific timings. As if someone was tracking Venus with the precision of modern orbital mechanics. But Venus is tricky. Its movements are complex. You can't predict its patterns without understanding that it orbits the Sun, not Earth. And the ancient Mesopotamians supposedly believed Earth was the center of everything. So how did they get it right? Hold that thought, because there's something even more impossible. Precession. Earth wobbles on its axis like a spinning top slowly losing momentum. This wobble takes 25,920 years to complete one full cycle. It's called the precession of the equinoxes, and it changes where the stars appear in the sky very, very gradually. So gradually that you can't notice it in a single lifetime, or even in 100 lifetimes. Modern astronomy discovered precession in the 1600s. Precise measurements, telescopes, centuries of accumulated data. But ancient texts describe it. They knew the stars shifted positions over vast spans of time. They calculated the rate of change. They built the precession cycle into their calendars and their mythology. The Greek astronomer Hipparchus gets credit for discovering precession in 130 BCE, but Babylonian tablets from 1,000 years earlier show they already knew. They had the numbers. They understood the cycle. And here's what makes no sense. To observe precession accurately, you need detailed star charts spanning at least several centuries, preferably millennia. You need multiple generations of astronomers all making precise measurements and passing that data forward without error. Did the Babylonians do that? Starting when? And how did they maintain that level of precision for thousands of years before writing even existed in many cases? Or did someone give them the numbers? Now let's talk about something called the Nineveh constant. It's a number that appears in Assyrian astronomical texts. 2,268,000,000 days. Sounds random. But when mathematicians analyzed it, they discovered something shocking. This number relates to the orbital periods of every planet in the solar system. Moon, Mercury, Venus, Earth, Mars, Jupiter, Saturn. The Nineveh constant is a common multiple, a number that all these different orbital periods can divide into evenly. It's like finding a number that both 12 and 15 can go into without remainders. Except instead of 12 and 15, it's the incredibly complex orbital periods of 7 different celestial bodies. Bodies that move at different speeds, in elliptical orbits, with gravitational interactions that affect their timing. Calculating this requires understanding orbital mechanics, planetary masses, gravitational forces, the kind of math that Newton developed in the 1600s. Yet this number appears in tablets from 2,500 years ago, written by astronomers who supposedly thought the planets were gods riding chariots across the sky. The math doesn't lie. Someone calculated that number, and they did it with an understanding of the solar system that shouldn't have existed until telescopes and calculus. But it gets better, or worse depending on how comfortable you are with impossible things. Babylonian ephemerides. These are tables predicting where planets will be in the sky on specific future dates. And they're accurate. In 1957, Otto Neugebauer published a book called The Exact Sciences in Antiquity. He spent decades studying Babylonian astronomical texts, and he found that their planetary predictions match modern calculations with precision that defies explanation. They predicted lunar eclipses centuries in advance, planetary conjunctions, solstices, equinoxes, all without computers, without telescopes, without even accurate clocks to measure time precisely. Yet their predictions work. You can use their tables today, adjust for precession, and predict celestial events accurately. How is that possible? Neugebauer couldn't answer that question. He documented what they achieved, but he couldn't explain how they achieved it. Because the observational requirements are staggering. You'd need centuries of night-by-night observations, perfect record-keeping, mathematical models that account for orbital variations. And somehow, the ancient astronomers had all of that. From the very beginning, their earliest astronomical texts already show sophisticated understanding, as if they started with advanced knowledge instead of building it gradually. Now, let's go even further back. Göbekli Tepe in Turkey. It's a temple complex from 9600 BCE, 11,000 years ago, before agriculture, before cities, before writing. Yet the stone pillars are aligned with astronomical precision. Klaus Schmidt, the archaeologist who excavated the site, found that the entire complex tracks celestial events, solstices, equinoxes, specific star positions. Hunter-gatherers built this. People who supposedly lived in small bands. No centralized government. No writing system to record observations. Yet they encoded astronomical knowledge into stone with precision that requires understanding cycles spanning decades, or even centuries. Schmidt wrote that the astronomical alignments suggest knowledge that couldn't have been developed by the community that built it. The knowledge had to come from somewhere else. But from where? The texts say the Anunnaki, the gods from the sky, the teachers. And what did they teach? According to Hermann Hunger and David Pingree in their book Astral Sciences in Mesopotamia, ancient priests possessed mathematical astronomy that treated celestial bodies as moving according to numerical patterns, not as gods, not as mythological entities, as objects following mathematical rules. That's a scientific worldview. That's treating the universe as something that can be understood through calculation and prediction. That's modern astronomy disguised in ancient language. And here's something that will make your head spin. The Dogon people of Mali in West Africa. French anthropologists studying them in the 1930s recorded detailed astronomical knowledge in their oral traditions. The Dogon described Sirius, the brightest star in our night sky. But they didn't just know Sirius. They knew about Sirius B, a white dwarf companion star that orbits Sirius A. Sirius B is invisible to the naked eye. Completely invisible. It wasn't discovered by modern astronomy until 1862, when telescopes became powerful enough to see it. Yet the Dogon traditions, passed down for generations, described it. They said Sirius had a companion. They knew its orbital period, 50 years, which is correct. They knew it was small but incredibly dense. Also correct. White dwarfs are tiny stars with enormous mass packed into a small space. How did they know? The standard explanation is contamination. Maybe Western astronomers told them in the early 1900s, and they incorporated it into their traditions. But the Dogon say their knowledge is ancient, passed down from the Nomo, beings who came from Sirius in ancient times, and taught them about the stars. Sound familiar? Sky beings teaching astronomy. Advanced knowledge appearing in cultures that supposedly couldn't have acquired it naturally. The same pattern, repeating across continents and millennia. Now, you might be thinking, okay, but couldn't ancient people have just been really good observers? Couldn't they have figured all this out through careful measurement over long periods? And the answer is, maybe, for some of it, but not all of it. Not the precision, not the mathematical sophistication, not the understanding of concepts that require instruments they didn't have. Take eclipse prediction. To predict eclipses accurately, you need to understand that the moon orbits Earth and Earth orbits the sun. You need to know the orbital periods precisely. You need to account for the moon's elliptical orbit, the sun's apparent motion, the inclination of the moon's orbit relative to Earth's equator. All of these factors affect when and where eclipses occur. The Babylonians predicted eclipses centuries in advance, with accuracy that rivals modern calculations. And they did it without understanding heliocentrism. Officially, they believed Earth was the center. Yet, their math implies they understood orbital mechanics. Either they had the right answers for the wrong reasons, which seems unlikely given the precision, or they knew more than their official cosmology suggested. This is where it gets uncomfortable for historians, because the evidence suggests ancient astronomers possessed knowledge they shouldn't have had. Either they made observations spanning thousands of years with perfect continuity and record-keeping, or they inherited knowledge from an earlier source, a source with advanced understanding. The texts explicitly say the latter. Enki taught astronomy. The Anunnaki showed humans how to track the stars, how to calculate celestial cycles, how to predict eclipses and planetary positions. And for centuries, scholars dismissed this as mythology. But the astronomical texts prove the knowledge existed, prove it was accurate, prove it was mathematically sophisticated. So we can't dismiss the source claims just because they sound impossible. Because the knowledge itself is impossible by conventional understanding. And here's the detail that should really make you pause. Mesopotamian astronomical knowledge degrades over time. Their earliest texts are the most accurate. As centuries pass, the precision decreases. Errors creep in. The mathematics becomes less sophisticated. That's backwards. Knowledge is supposed to improve as civilizations advance. You should see better astronomy in later periods, not worse. Unless the original knowledge was inherited, not developed. And as generations passed without updates, without new instruction, the knowledge slowly corrupted. Copied and recopied. Details lost. Understanding fading. Like a game of telephone played across millennia. The information survives, but the precision erodes. In 2020, the University of Vienna analyzed Mesopotamian lunar eclipse predictions across different time periods. Early Babylonian predictions are more accurate than later ones. The knowledge was best at the beginning. Then it declined. That pattern suggests inheritance from an advanced source, followed by gradual loss of precision as the original understanding faded. But here's the part that ties everything together. Astronomical knowledge wasn't just academic for these ancient civilizations. It was power. The priests who could predict eclipses controlled the calendars. They determined planting seasons. They validated royal authority. They claimed to speak for the gods because they could predict when the gods would appear in the sky. Venus rising, Mars aligning with certain stars, the moon darkening during an eclipse. To an ancient population, this looked like magic, like divine communication. But it was astronomy, advanced astronomy, that the priests guarded jealously. They didn't share the mathematical details. They kept the knowledge secret, passed it down through specialized schools, maintained their power through prediction. The texts describe the Anunnaki doing something similar, teaching select individuals, creating a priest class, keeping certain knowledge restricted. Why? Because knowledge is control. If you can predict celestial events, you can claim divine authority. You can organize agriculture. You can coordinate large-scale projects by telling people when to plant, when to harvest, when to expect floods or droughts based on stellar positions. And all of that requires astronomy, precise astronomy. The kind that takes either millennia to develop or advanced instruction to transmit. Modern science took 2,000 years after Greece to rediscover what Babylonians knew. From the ancient Greeks, through the medieval period, through the Renaissance, we slowly, painfully rebuilt astronomical knowledge that ancient texts already contained. Why? If humans figured it out once through pure observation, why did it take so long to figure it out again? Why did knowledge regress instead of progress through most of human history? The conventional answer is that knowledge was lost. Libraries burned, civilizations collapsed, the continuity broke. And sure, that happened. But it doesn't fully explain why ancient astronomy was so advanced to begin with, so precise from the very start, as if the foundation was already in place and later civilizations were just trying to reconstruct what had been lost. So we're left with two possibilities. Either ancient humans achieved astronomical precision that rivals modern measurements through pure observation and dedication over thousands of years, maintaining perfect records and mathematical sophistication through pre-literate periods. Or they received instruction. They were taught, given tables and formulas and understanding that they preserved as best they could, even as the original meaning faded. The texts say the second option. The Anunnaki taught astronomy. And modern validation of that ancient astronomy suggests the teaching was real. The knowledge was accurate. Someone knew how the cosmos worked, and they passed that knowledge to humans. But here's what that means. Astronomical knowledge isn't just about tracking stars. It's about building, creating structures aligned with celestial events. Monuments that mark solstices and equinoxes, temples oriented to specific star risings, architecture that encodes cosmic understanding in stone. And when we look at ancient architecture, we find the same impossible precision. Structures aligned to true north with accuracy that requires instruments we don't think they had. Buildings that track celestial events with engineering that we struggle to replicate, even with modern tools. Monuments that suggest whoever built them understood geometry, astronomy, and construction at levels that don't match the primitive technology we assume they possessed. Astronomical knowledge enables architecture aligned with the cosmos. Which brings us to the engineering impossibilities. structures built with precision we struggle to match today. Massive stones, cut and placed with tolerances tighter than modern construction. Acoustic properties designed into chambers. Hydraulic systems that shouldn't exist for thousands of years. And all of it raising the question, did ancient builders possess lost techniques, or did they have assistance from sources with advanced knowledge? Take up a ruler. Look at the finest measurements you can see. Now imagine cutting stone blocks that fit together with tolerances tighter than that. 1/100th of an inch. Precision that modern construction rarely achieves. Now imagine doing it with copper tools and stone hammers. In 1500 BCE. That's Pumapunku in Bolivia, and engineers who study it can't explain how it was done. The blocks are andesite and diorite, some of the hardest stones on Earth. You can't scratch them with copper. You can't shape them with bronze. Modern stonemasons use diamond-tipped power tools. And even with those tools, matching the precision at Pumapunku is extremely difficult. Yet someone did it, thousands of years ago, with technology that supposedly didn't exist. So how? The astronomical knowledge we just explored showed that ancient civilizations possessed information they shouldn't have had. But you can dismiss astronomical data as abstract. Maybe they got lucky. Maybe they extrapolated from limited observations. But architecture? Architecture is physical, undeniable. You can measure it, test it, try to replicate it. And when modern engineers attempt to recreate ancient construction using the tools we think were available, they fail, consistently. That's not theory. That's not speculation. That's measurable, documented failure to match ancient precision with reconstructed ancient technology. Which means something is very wrong with our understanding of the past. Let's start with the precision problem, because once you understand the numbers, you'll realize why this is so disturbing. Modern building codes allow tolerances of about 1/8 of an inch for most construction. That's considered acceptable for commercial and residential buildings. But ancient structures consistently show tolerances of 1/50th of an inch or better. At Pumapunku, some joints measure 1/100th of an inch. You can't slip a credit card between the stones. And these aren't small decorative pieces. These are multi-ton blocks. Massive stones that had to be quarried, transported, shaped, and fitted with precision that requires measuring instruments we don't think existed. Laser levels? No. Precision calipers? No. Computer-guided cutting? Obviously not. Yet the results match or exceed what modern technology achieves. Christopher Dunn, an engineer who specialized in precision manufacturing, analyzed the Great Pyramid at Giza. He spent decades working with high-tolerance equipment, making parts for aerospace applications where precision is crucial. And when he measured the pyramid blocks, he found tolerances that matched his manufacturing standards. But the pyramid was built 4,500 years ago, with copper tools, stone pounders, wooden wedges. The math doesn't work. Copper is too soft to cut granite effectively. Stone pounders leave irregular surfaces, not flat planes. Wooden wedges split stone along natural fracture lines, not in perfectly straight cuts. Yet the pyramid blocks show perfectly flat surfaces. Precise 90-degree angles, joints so tight that you can barely see the seams. Dunn wrote in his book, The Giza Power Plant, that the evidence suggests machining, power tools, advanced cutting technology. And he's not a fringe theorist. He's a precision engineer who spent his career working with tolerances measured in thousandths of an inch. He knows what precision looks like, and he's telling you that ancient Egypt achieved it. But it gets stranger. The Great Pyramid isn't just precisely built, it's precisely aligned. True north, within 3/60ths of a degree. That's less than the width of a human hair when projected across the base of the pyramid. How do you achieve that alignment? With a compass? Compasses point to magnetic north, not true north. And magnetic north wanders. It shifts over time.
True north is a calculation. It requires astronomical observation, careful measurement, mathematical adjustment. The ancient Egyptians supposedly didn't have accurate compasses. They didn't have GPS. They didn't have satellite navigation. Yet they aligned a structure weighing 6 million tons to true north, with accuracy that most modern buildings don't achieve. The margin of error is so small that some researchers think it was deliberate. A demonstration of capability. As if the builders were saying, "Look what we can do." And inside the pyramid, there's more impossible engineering. The king's chamber is made of granite blocks weighing up to 80 tons each. They were lifted 300 feet into the air, placed with millimeter precision. And somehow, the chamber has acoustic properties that shouldn't be accidental. When you make sound in that chamber, specific frequencies resonate. The granite amplifies certain tones, creates standing waves, as if the room was designed as a resonance chamber. Why would a tomb need acoustic engineering? Unless it wasn't a tomb. Unless it had another purpose. A purpose that required precise manipulation of sound frequencies in a sealed granite chamber, high inside a massive stone structure. Hold that thought, because acoustic engineering appears in other ancient sites too. And it's even older than the pyramids. Göbekli Tepe in Turkey, 11,000 years old. Built by hunter-gatherers who supposedly had no writing, no metallurgy, no centralized government. Yet in 2017, researchers published a study in the Journal of Acoustic Engineering, documenting something remarkable. The T-shaped pillars at Göbekli Tepe manipulate sound. When you play certain frequencies, the stone resonates. The pillars vibrate at specific pitches. The entire structure acts like a musical instrument. Or, more accurately, like an acoustic device designed to focus and amplify particular sound frequencies. Why? Hunter-gatherers building acoustic resonators 11,000 years ago. That requires understanding wave mechanics, harmonic frequencies, material properties of stone. Klaus Schmidt, who led the excavation, wrote that the sophistication suggests knowledge that the builders couldn't have developed on their own. The site appears fully formed. No gradual development, no trial and error. Just advanced acoustic engineering, appearing suddenly in the archaeological record, as if someone taught them. Now, let's talk about water.
Because ancient hydraulic engineering is just as impossible as the stonework. Mohenjo-Daro, in the Indus Valley, built around 2600 BCE. The city has a drainage system that modern sanitation engineers call remarkably advanced. Every house connected to covered drains, standardized pipe sizes, inspection chambers for maintenance. The entire city planned around water management and waste removal. The Archaeological Survey of India documented brick sizes at Mohenjo-Daro. They're standardized, perfectly uniform ratios, 4:2:1. Every brick the same dimensions. That requires centralized manufacturing, quality control, understanding of structural loads and stress distribution. It's industrial-scale production before we think industry existed. And the drainage itself shows understanding of gradients, flow rates, and public health that supposedly wasn't discovered until the 19th century. Yet someone in 2600 BCE knew that standing water breeds disease, knew that waste needs to be removed from living areas, knew how to engineer a city-wide system that would remain functional for centuries. How did they know? But if you think ancient water engineering is impressive, wait until you see the stones they moved. Baalbek in Lebanon. The foundation platform contains blocks weighing 1,200 tons each. That's 2,400,000 pounds. Modern cranes can't lift that much weight. The largest crawler cranes in the world max out around 3,000 tons, and those require massive support structures, counterweights, and careful engineering to operate safely. Yet, at Baalbek, 1,200-ton stones sit precisely placed in a foundation. Not roughly positioned, precisely fitted, with neighboring stones also weighing hundreds of tons. No modern crane could have placed those stones. No ancient technology we know of could have moved them. Yet there they are, perfectly positioned, and no one knows how. The standard explanation is ramps and leverage, but the math doesn't work. A 1,200-ton stone on wooden rollers would crush the wood. Stone rollers would require teams of thousands pulling with ropes, and archaeological evidence for such massive ramps absent. We should find enormous quantities of construction debris, mountains of rubble from ramp building, wear patterns from rope friction, tool marks from excavation. But we don't find evidence of the infrastructure that moving these stones should require. So what moved them? In the 1920s and 30s, a man named Edward Leedskalnin built Coral Castle in Florida, single-handedly. He moved stones weighing multiple tons, carved them precisely, fitted them together with minimal tools, and he claimed to have rediscovered the technique used by ancient builders. He spoke of understanding weight, leverage, and principles that modern physics had forgotten. He died without revealing his methods, but he demonstrated that one person with knowledge could move massive stones without modern equipment. If one person could do it in the 20th century, could ancient builders have known similar techniques? Techniques lost to history. Techniques that physics textbooks don't cover, because we've forgotten they exist. Or is there another explanation? Here's where we need to talk about the tool problem. Because at many sites with advanced stonework, We don't find the tools that should have been used. No bronze saws at Pumapunku. No evidence of diamond abrasives at Egyptian quarries. No tool marks that match copper implements on diorite statues. The technology needed to create these structures is absent from the archaeological record. It's like finding a modern skyscraper in the fossil record, but no power tools, no steel mills, no evidence of the industrial infrastructure needed to build it. The end result exists. The means of production? Missing. Modern engineers have tried to fill this gap. They've attempted to replicate ancient construction using reconstructed tools, and the results are consistently disappointing. In 1991, a team tried to build a scaled-down pyramid using ancient Egyptian techniques as understood by mainstream archaeology. Copper tools, stone pounders, wooden sleds. They struggled to move stones weighing just a few tons. The precision was crude, the time required was enormous, and they were working with a fraction of the scale and precision of the actual pyramids. Similar experiments with Pumapunku failed even more dramatically. Modern stonemasons using reconstructed ancient tools couldn't achieve anything close to the precision of the original blocks. Not even close. Not within an order of magnitude. The ancient builders weren't just slightly better than modern attempts. They were operating at a completely different level of capability. Which brings us to the lost technique hypothesis. Maybe ancient builders knew methods we've forgotten. Maybe they had knowledge of acoustic levitation, using sound frequencies to reduce the effective weight of stones. Maybe they knew chemical techniques to soften stone temporarily, shape it, and let it harden again. Maybe they understood principles of leverage and mechanical advantage that modern engineering has overlooked. These sound like science fiction. But so does precision machining with copper tools. So does moving 1,200-ton stones without cranes. Everything about these sites sounds impossible, yet they exist. So we're choosing between multiple impossibilities. Which one is least impossible? The ancient texts offer a different answer. The Anunnaki taught construction. They showed humans how to cut stone, how to move massive blocks, how to create structures aligned with celestial events. And for centuries we dismissed this as mythology. Gods teaching architecture? Ridiculous. Except the architecture exists. The precision is real. The engineering is validated. And we can't replicate it with the tools we think were available. So maybe the texts aren't lying. Maybe they're describing something that actually happened. Advanced beings teaching primitive humans sophisticated techniques. Not magic. Not supernatural intervention. Just knowledge transfer. Engineering instruction from sources that already understood principles we're still rediscovering. But here's where it gets complicated. If advanced beings taught these techniques, why wasn't the knowledge preserved? Why didn't they leave detailed instruction manuals? Why mythological references instead of engineering blueprints? Technical knowledge should be written down explicitly, step-by-step procedures, mathematical formulas, diagrams. Yet we get stories about gods and miracles instead. Unless the knowledge was deliberately obscured, kept restricted, taught only to select individuals who then guarded it jealously. Because knowledge is power. If you're the only one who knows how to move massive stones or cut granite with precision, you're valuable, indispensable. You have authority that can't be challenged. So you don't write it down. You don't share it widely. You teach your apprentices carefully, selectively, and maintain your monopoly on the technology. That would explain why the knowledge degraded over time, as master builders died without fully training their students, as political upheavals disrupted teaching lineages, as techniques became simplified and precision was lost. The structures remain. The capability fades. Until later civilizations look at these monuments and can't imagine how they were built. Because the knowledge is gone. The techniques are lost. All that remains is the physical evidence of what was once possible. Or maybe the Anunnaki stopped coming, stopped teaching, left humanity with partial knowledge and incomplete understanding. The texts talk about the gods departing, promising to return, leaving humans to fend for themselves. And if that's true, then what we see in the archaeological record makes sense. Advanced capabilities in early periods, gradual decline, techniques forgotten, standards lowering, until we reach civilizations that can barely maintain the structures their ancestors built, let alone create new ones at that level of sophistication. Now let's apply Occam's razor. The principle that the simplest explanation is usually correct. We have three options. 1. Ancient humans developed sophisticated engineering independently, using techniques we haven't discovered, despite decades of research and experimental archaeology. 2. They received instruction from advanced sources who taught them methods that were later lost. 3. We're dramatically underestimating ancient capabilities, and they figured it out through means we can't reconstruct because we're asking the wrong questions. Which is simplest? Which requires the fewest assumptions? And honestly, all three require assumptions that challenge conventional understanding. None of them are simple. None of them fit neatly into standard historical narratives. But the evidence doesn't care about our narratives. The evidence just sits there, precisely cut, perfectly fitted, acoustically engineered, hydraulically sophisticated, astronomically aligned, waiting for us to explain it. And the texts say the Anunnaki taught these skills, not as gods performing miracles, but as engineers teaching techniques, practical knowledge, applied science, building methods that produced results we can measure and verify, but can't replicate with the tools we think existed. So we're left with impossible architecture, undeniable precision, missing technology, and ancient accounts of beings who taught construction techniques to primitive humans. The pieces are all there. The question is whether we're brave enough to assemble them into a picture that challenges everything we've been taught about human history. Because these architectural achievements required more than technical skill. They required long-term planning, centralized coordination, massive resource allocation, and possibly, probably, knowledge passed down through generations, or perhaps through teacher-student relationships with beings who already possessed that knowledge, who came here with understanding that would take humans thousands of years to rediscover, who taught, then left, leaving behind structures that whisper of capabilities we've only begun to understand. In 2023, we're developing atmospheric geoengineering with particles, editing genes with CRISPR, building Mars colonies, discovering exoplanets. Every technology the Anunnaki texts describe, we're now creating ourselves. Are we innovating or remembering? Here's something that keeps scientists up at night. We've been digging in the Mesopotamian desert for over a century, and every time we uncover a new tablet, translate a forgotten text, or reconstruct an ancient library, we find the same disturbing pattern. The knowledge was already there, advanced, sophisticated, complete. As if someone handed humanity an instruction manual and said, "Good luck." Think about that for a second. When we look at human history, we expect to see gradual progress, right? Stone tools get better over thousands of years. Fire leads to cooking, leads to metallurgy. Slow, step by step. That's evolution. But that's not what the archaeological record shows. Around 3500 BCE, something extraordinary happens in Sumer. Not gradually, not over centuries. Almost overnight in historical terms, a civilization emerges with writing systems, legal codes, advanced mathematics, astronomical charts, and urban planning. They have the wheel. They have bronze metallurgy. They have agricultural irrigation networks spanning hundreds of miles. They even have a system of trade and commerce with standardized weights and measures. Where's the prototype phase? Where are the failed experiments? Where's the learning curve? It's like someone installed Civilization version 1.0 and hit enter. And here's where it gets interesting. Egypt does the same thing around 3100 BCE. The Indus Valley civilization appears fully formed around 2500 BCE. The Norte Chico culture in Peru, same story, roughly 3000 BCE. These aren't primitive tribes slowly figuring things out. These are complex societies with infrastructure, governance, and technical knowledge that shouldn't exist yet, according to mainstream archaeology. In 2021, researchers David Wengrow and David Graeber published a book called The Dawn of Everything that challenges everything we thought we knew about early human societies. They present evidence that our ancestors weren't simple hunter-gatherers waiting for agriculture to save them. They were sophisticated, experimental, and capable of complex social organization thousands of years before we gave them credit for. But even they can't fully explain the sudden appearance of writing. Writing, the technology that changes everything, that preserves knowledge across generations, that allows civilization to compound its discoveries instead of losing them. And it appears in Sumer essentially complete. Cuneiform isn't primitive scratches that slowly evolve into language. It's a fully functional system from the start, capable of recording everything from beer recipes to astronomical observations to legal proceedings. Who taught them? And more importantly, what else did they teach them? Now get this. When we examine these ancient texts, really examine them word by word, we find technical information that shouldn't be there. The Sumerians describe atmospheric composition. They discuss genetic inheritance. They map planetary movements with precision that wouldn't be matched again until the telescope. They encode mathematical constants into temple architecture. This isn't mythology. This is data. So how does knowledge like that survive for thousands of years? Especially when most people can't read and writing materials decay. The answer is clever. Brilliant, actually. You encode it in stories. Picture this. You're a priest in ancient Mesopotamia. You possess technical knowledge, maybe inherited from teachers long gone, maybe preserved from an earlier civilization, maybe both. You know that empires fall, libraries burn, languages die. But you also know that stories survive, myths endure, rituals persist. So you take your technical knowledge and you wrap it in narrative. The gene editing becomes a creation story. The astronomical data becomes astrology. The atmospheric engineering becomes a flood myth. You make it memorable. You make it sacred. You make it impossible to forget. And it works. In the 1940s, anthropologists observed something remarkable in the Pacific Islands. During World War II, indigenous people who had lived in isolation witnessed airplanes, radios, and military technology for the first time. They had no framework to understand what they were seeing, so they created one. They developed cargo cults, religious movements that performed rituals mimicking military behavior, believing it would summon the metal birds that brought supplies. They built wooden airplanes. They wore carved headphones. They cleared landing strips in the jungle. They described the technology they'd witnessed using the only language they had, the language of gods and spirits and magic. To them, the airplane wasn't a machine. It was divine. Hold that thought, because there's something else you need to know first. Ancient Sumerian texts describe beings who descended from the sky in vehicles that roared and glowed. The Sanskrit Vedas detail flying machines called vimanas with specific technical specifications. The Book of Ezekiel describes wheels within wheels, fire, and beings of light. Egyptian hieroglyphs show objects that look suspiciously like helicopters and submarines, though mainstream scholars insist they're just overlapping glyphs creating coincidental shapes. Now ask yourself, if cargo cult islanders described airplanes as gods in metal birds, how would ancient scribes describe technology 1,000 times more advanced? Exactly the same way. As researcher Graham Hancock points out in Fingerprints of the Gods, we've been reading these texts wrong. We've been calling them mythology, when we should have been calling them technical documentation. The language is primitive not because the knowledge is primitive, but because the witnesses lacked vocabulary to describe what they were seeing. When the Sumerian texts say the Anunnaki created humans by mixing the essence of the gods with the clay of the earth, we translate that as mythology. But what if it's biochemistry, described by someone who'd never heard the word DNA? What if clay means biological material? What if essence of the gods means genetic template? Suddenly the creation story becomes a cloning procedure. But here's where the story takes an unexpected turn. This kind of knowledge, advanced, technical, powerful knowledge, doesn't just stick around forever. It disappears. And it disappears catastrophically. In 48 BCE, the Library of Alexandria burns. Some estimates suggest it contained 400,000 scrolls, maybe more. Entire fields of knowledge vanished in days. Ancient scientific texts, astronomical charts, medical procedures, engineering treatises, mathematical proofs. Gone. And Alexandria wasn't the only one. The House of Wisdom in Baghdad, destroyed in 1258. The Mayan codices, burned by Spanish priests who called them devil worship. The Library of Nalanda in India, razed for months by invaders. Over and over, humanity's accumulated knowledge goes up in flames. What technologies did we lose? What understanding of the natural world? What techniques for medicine, construction, navigation? We'll never know. That's the point. But sometimes the knowledge echoes. It persists in fragments, in folk remedies that actually work, in architectural tricks that modern engineers rediscover, in astronomical alignments that shouldn't be possible without computers. In 2012, geologist Robert Schoch published research suggesting the Great Sphinx of Egypt shows water erosion patterns consistent with rainfall around 7000 BCE or earlier. That's 4,000 years before conventional dating. 4,000 years before Egypt supposedly had the technology to carve it. If he's right, and the debate continues, then an advanced civilization existed and vanished before recorded history begins. A civilization we've forgotten entirely. Now think about technological progress in our own era. We like to imagine it's linear. Each generation builds on the last. Knowledge compounds. We only move forward. That's not what happened. Roman concrete technology was superior to anything we used until the 20th century. We're still figuring out how they made it. Greek fire, the Byzantine weapon that burned on water, remains a mystery. Damascus steel, with its distinctive patterns and unmatched sharpness, we can't reproduce, despite all our metallurgical knowledge. The Antikythera mechanism, an ancient Greek analog computer that predicted astronomical positions. We didn't build anything that complex again for over 1,000 years. These aren't myths. These are documented technologies that existed, worked, and were completely lost. Progress isn't a straight line, it's a cycle. Knowledge appears, knowledge disappears. Knowledge appears again. And every time it returns, we call it innovation. But what if it's just remembering? In the ancient world, technical knowledge wasn't public. It was monopolized by a priest-scientist class who understood that knowledge is power. They encoded their discoveries in religious rituals, architectural proportions, and mythological narratives accessible only to initiates. The Egyptian mystery schools, the Babylonian astronomers, the Mayan calendar keepers. They weren't just spiritual leaders. They were engineers, mathematicians, physicists, and they wrote everything down in code. The Pyramid of Giza encodes pi, phi, and the speed of light in its proportions. The Mayan long count calendar predicts planetary alignments thousands of years in advance. The Antikythera mechanism calculated eclipse cycles using gear ratios we didn't understand until we X-rayed it. These aren't coincidences. These are deliberate messages from people who knew their civilization wouldn't last forever. They were leaving breadcrumbs. Which brings us to the most uncomfortable question of all. The one nobody wants to ask. What if this has happened before? Not once. Multiple times. What if Earth has hosted previous technological civilizations that rose, fell, and vanished so completely that all we have left are myths? According to Jared Diamond's research in Guns, Germs, and Steel, civilizational success depends on geography, resources, and biological luck. But that model assumes linear development. It doesn't account for the sudden appearance of sophisticated knowledge or the catastrophic loss of it. What if the pattern isn't geographical? What if it's cyclical? There's a hypothesis, controversial but persistent, that advanced civilizations have emerged multiple times throughout Earth's history. They develop technology. They flourish. Then something happens. Cataclysm, war, environmental collapse, and they vanish, leaving only ruins and stories. Stories that the next civilization interprets as mythology about gods. But here's the thing. If that hypothesis is true, we should find evidence. We should find anomalies in the archaeological record, technologies that don't belong, knowledge that appears too early, structures that shouldn't exist. And we do. Over and over, we do. The question isn't whether advanced knowledge existed in the ancient world. The question is where it came from. Did ancient humans independently develop these insights? Was there an earlier human civilization we haven't discovered? Or did someone teach them? Someone like the Anunnaki. Whether you interpret that as extraterrestrial visitors, time travelers, or survivors of a previous advanced civilization, the pattern remains the same. Knowledge transmission. Teachers and students. Instruction and inheritance. And now comes the strangest part. The part that makes everything we've discussed feel suddenly, urgently relevant. We're repeating the pattern. Right now. In our lifetime. In the 2010s, we developed plasmonics, manipulating light at the nanoscale using gold particles. The Anunnaki texts describe using gold dust for atmospheric purposes. Coincidence? In 2012, we invented CRISPR gene editing. The creation myths describe mixing genetic essences to create humans. Parallel development? In the 2020s, we're seriously discussing geoengineering Earth's atmosphere and colonizing Mars. The ancient texts describe exactly those activities. Independent innovation? Or are we rediscovering what was known before? Here's what keeps me up at night. Every technology attributed to the Anunnaki in those ancient texts we're developing now. We're not creating entirely new concepts. We're reaching technological levels that allow us to finally understand what the ancient texts were describing all along. We're becoming them. The advanced civilization. The knowledge keepers. The teachers preparing to spread to other worlds. In a few decades, maybe a century, humans will establish permanent colonies on Mars. We'll bring technology. We'll bring genetic modifications for surviving low gravity and high radiation. We'll bring knowledge. And if something catastrophic happens to Earth, if our civilization collapses, those Mars colonies might survive. Thousands of years later, what will their descendants remember? Will they know they came from Earth? Or will they tell stories about beings who came from the sky, brought knowledge, and created their ancestors? Will they call those beings gods? As we prepare to become the Anunnaki for future Mars colonies, bringing technology, genetic modifications, and knowledge to a new world, we must confront the final question. What happens when the students become the teachers? SpaceX engineers designing Mars habitats, CRISPR scientists editing human embryos, geoengineering researchers planning atmospheric interventions. We are becoming the Anunnaki of our own myth, which raises one terrifying question. Will future archaeologists describe us as gods? Right now, at this exact moment in history, humanity stands at a threshold. We're developing every single technology the ancient texts attributed to those mysterious beings from the sky. Genetic engineering, atmospheric manipulation, space colonization, resource extraction from other worlds. We're not reading about it anymore. We're doing it. And that changes everything. Let's start with Mars, because Mars is where this story stops being ancient history and becomes our immediate future. Elon Musk wants 1 million people living on Mars by 2050. That's not science fiction. That's a business plan with hardware already being tested. SpaceX is building the rockets.
NASA is developing the habitats. Engineers worldwide are solving the technical problems of surviving on a frozen, airless rock 40 million miles from home.
But here's the thing nobody talks about, the part that makes you uncomfortable when you really think about it. Humans can't survive on Mars as we are, not long term. The gravity is wrong, the radiation is lethal, the atmosphere is poison. So what do? We change Mars to suit us, or we change us to suit Mars. Terraforming or genetic modification, those are the options. Sound familiar? Because it should. It's exactly what the Sumerian texts describe. The Anunnaki came to Earth, found conditions that didn't quite work for them, and made modifications. They altered the atmosphere. They engineered workers adapted to local conditions. They established mining operations for resources they needed. They did to Earth what we're planning to do to Mars. Now get this. In 2018, a Chinese scientist named He Jiankui announced he'd used CRISPR to edit human embryos. Twin girls born with modified DNA resistant to HIV infection. The scientific community erupted. Ethics boards condemned him. He went to prison. But the technology exists. The capability is real. And the National Academy of Sciences has already published guidelines, not prohibitions, guidelines, for when and how genetic editing of human embryos might be acceptable. We're debating the same questions the ancient texts raise. When is it acceptable to modify human genetics? Who decides what changes are permissible? What happens when you create humans specifically designed for certain tasks or environments? The Atrahasis describes beings created to labor in specific conditions. We call that mythology. But when we discuss engineering humans with radiation resistance for Mars colonies, or enhanced bone density for low-gravity environments, what are we calling that? Progress. Hold that thought, because there's something else you need to know first. In 2019, Harvard University proposed a project called SCOPEX, the Stratospheric Controlled Perturbation Experiment. The plan? Release particles into Earth's upper atmosphere to reflect sunlight and combat global warming. They'd use calcium carbonate, basically chalk dust. Other proposals suggest sulfur dioxide. Some recommend seeding clouds with reflective materials. All of them involve deliberately manipulating Earth's atmospheric chemistry on a planetary scale to alter climate. We are seriously discussing geoengineering, not as science fiction, as policy. The ancient texts describe the Anunnaki manipulating atmospheric conditions. We've spent 6 chapters examining how that might relate to gold nanoparticles and plasmonics. But maybe we've been missing the point. Maybe the important part isn't what they used. It's that they were willing to do it at all. To treat a planet's atmosphere as something you can engineer, something you should engineer, To have that level of technological hubris. We're there now. But here's where the story takes an unexpected turn, because we're not just repeating what the Anunnaki allegedly did. We're adding something new, something that wasn't in the ancient texts at all. Artificial intelligence. Think about what AI represents. We're not just passing on knowledge anymore. We're creating new minds, new intelligence that doesn't evolve naturally, but springs fully formed from human design. Intelligence that might exceed our own. Intelligence that could outlive us, outlast us, and make decisions about Earth's future without consulting the biological beings who created it. As philosopher Nick Bostrom points out in his book Superintelligence, we might be creating the last invention humanity ever needs to make. Because once artificial intelligence exceeds human capability, it could do all subsequent inventing itself. The Anunnaki, if they existed, modified existing life forms and passed on existing knowledge. We're doing something unprecedented. We're creating entirely new categories of mind. That's not in the instruction manual. Which brings us to the question that matters, the one we've been dancing around for 6 chapters. Are we wise enough to wield these godlike capabilities responsibly? Because here's the uncomfortable truth. If the Anunnaki story is real, it didn't end well. The texts describe conflicts, catastrophes, floods that wiped out civilizations, beings who created life getting into wars that destroyed it, knowledge that elevated humanity but also endangered it. If it's a warning, we should probably listen. But what if our civilization collapsed tomorrow, right now? What if some disaster struck that fragmented our knowledge, destroyed our digital records, and scattered humanity into isolated groups struggling to survive? 1,000 years from now, what would future archaeologists make of us? They'd find ruins of nuclear power plants without understanding fission. They'd discover genetic laboratories without comprehending DNA editing. They'd uncover plans for Mars colonies without grasping the engineering required. They'd piece together fragmentary records of artificial intelligence without having working computers. How would they describe us? What stories would they tell about the beings who could edit life, control the weather, and reach for other worlds? They'd call us gods, obviously, just like we call the Anunnaki gods. Not because they were divine, but because their technology was so far beyond the comprehension of later generations that mythology became the only framework available to describe them. We're creating that same gap, right now, between what we can do and what future generations might understand if knowledge is lost again. The cycle continues. And here's what keeps me up at night. We're already mining asteroids. Not science fiction, not distant future. Present tense. Companies like Planetary Resources and Deep Space Industries have actual plans, actual technology, actual proposals to extract water, precious metals, and rare elements from asteroids. The Anunnaki texts describe coming to Earth for gold mining. We laughed at that. We called it mythology. But asteroid mining for rare resources? That's just good economics. When we finally establish that Mars colony, when we send modified humans to live in engineered habitats on a terraformed world, when we mine asteroids for resources Earth lacks, we won't be innovating. We'll be following a template that's been in the clay tablets all along. So here's the real question, the one that ties everything together. Are the Anunnaki texts warning or blueprint? Cautionary tale or instruction manual? Did ancient scribes describe beings who wielded dangerous technology unwisely, encoding a message for future generations about the perils of playing God? Or did they document successful planetary engineering that we should emulate when our turn comes? Maybe both. Maybe that's the point. Technology itself isn't good or evil, it's capability. What matters is wisdom, ethics, responsibility. The Anunnaki texts, whether literal history or elaborate metaphor, ask us to confront what happens when technological capability exceeds ethical development. We have the power to edit human genes. Do we have the wisdom to choose which edits are acceptable? We can manipulate planetary atmospheres. Do we understand the full consequences? We're creating artificial minds. Do we comprehend what we're unleashing? These aren't abstract philosophical questions anymore. They're decisions we're making right now. In laboratories, in boardrooms, in government policy. And there's another layer to this, something researcher Graham Hancock and others have suggested. What if technological knowledge embeds in cultural memory more deeply than we realize? What if our innovations aren't entirely original, but partial rediscoveries of things humanity once knew? When ancient texts describe genetic engineering and we independently develop CRISPR, is that parallel evolution or inherited memory surfacing after millennia of dormancy? When myths describe atmospheric manipulation and we propose geoengineering, are we innovating or remembering? We can't prove it either way, but the pattern is undeniable. Every capability attributed to the Anunnaki, we're developing. Not slowly, not gradually. In the span of a single human lifetime, we've gone from theoretical genetics to editing embryos. From dreaming about space travel to planning permanent Mars colonies. From wondering about climate control to actively debating planetary geoengineering. If this is coincidence, it's a remarkable one. Which brings us to the final implication, the one we've been building toward since Chapter 1. If we succeed, if we establish thriving colonies on Mars, if we create genetically modified humans adapted to alien environments, if we pass our knowledge to those future generations, what responsibility do we have? Because we will become the teachers, the advanced beings bringing knowledge to a new world. We will make decisions about what to share, what to withhold, how to encode crucial information for preservation. We'll determine what those future colonists know about Earth, about humanity's origins, about the technology that allowed their existence. And if something goes wrong, if some disaster cuts Mars off from Earth, if our colonies survive, but our civilization here collapses, those Martian descendants will tell stories about us. Stories about beings from the blue planet who came from the sky, brought technology and knowledge, and created their ancestors. They'll describe capabilities that seem magical. They'll encode technical information in mythological language. They'll argue for centuries about whether we were real or merely symbolic. They'll call us the Anunnaki. The cycle completes. So here we are, at the end of this investigation into ancient texts, impossible technologies, and mysterious beings from the sky. We started by asking whether the Anunnaki were real. We examined their supposed technologies one by one. We traced patterns of knowledge transmission through history. And we've arrived at this moment, this threshold, where the question isn't whether they existed. The question is what we do with the power we've inherited or rediscovered. Because whether the Anunnaki were extraterrestrial visitors, survivors of an earlier human civilization, or symbolic representations of technological capability, they serve as mirror. They show us what we're becoming. They warn us about the consequences of wielding godlike power without godlike wisdom. They remind us that every advanced civilization faces these same choices: create or destroy, elevate or endanger, share knowledge or hoard it, act responsibly or recklessly. The story of the Anunnaki isn't really about the past. It never was. It's about the future. Our future. The one we're building right now with every genetic edit, every geoengineering proposal, every plan for space colonization, every advancement in artificial intelligence. We are the Anunnaki. We always were. The texts weren't describing alien gods. They were describing us, our potential, our power, our choices. And the question that matters, the only question that's ever mattered, is simple. What kind of gods will we choose to be?